All right, kinematics is a set of equations relating velocity, time, displacement, and acceleration. So it's a way to go through these things that we have that are more complicated. Okay, so let's do an example problem together, and I'll kind of show you what we're getting at, and I'll show you what the troubles are here. So a car driving 10 meters per second slams on the brakes. When we see the driver sees a little girl running in the street chasing a ball. If the acceleration of the car is -7, how far does the car go before coming to a stop? So here is my car traveling forward at 10 meters per second. It's going to come to a stop. It has an acceleration opposite direction of -7. But it doesn't give us time, so I'm not going to write a time on here because it doesn't say anything about time, right? It says, how far does the car travel? Okay, so let's draw our distance symbol like we've done before. And we'll just write D there. So I'm kind of combining my velocity and my acceleration drawings. So my acceleration drawings show before and after, and then an acceleration underneath. My distance and velocity drawings showed like a line showing the direction that we're going forward. Okay. So we labeled the things, we set it up. Now we're ready to use the equation. So it wants to know how far does the car travel before coming to a stop. So we got V equals D over T. So the velocity is 10, it starts off with, talking about. We're solving for displacement. But we need to know the time, and it doesn't give me the time. It doesn't say solve for time. It doesn't say anything about time. But we're creative here. We do know there's another equation, A equals delta V over T. And we can solve for T using that equation. So A is -7. Delta V is final minus initial, so it ends up at 0, and it started at 10. So 0 minus 10 divided by T. Always multiply the bottom to both sides. Where did I put my calculator? This will do. So 10 divided by 7 gives me, and I'll divide the -7 over, so that gives me a time of 1.4 seconds. So now I'm going to take my time that I just found, I'm going to put it over here. Going to multiply the bottom to both sides. And we get a distance of 14 meters. Okay, not so bad, except that's wrong. You're welcome. We just solved that whole problem and it's totally wrong. It doesn't work. You can't do that. Okay, here's why you can't do that. Remember V equals D over T? We said it only works if the acceleration is 0. And guess what? It's not. So we can't use that equation. Which means we can't solve time that, well, we can solve time that way, but the time doesn't work with the displacement. And so that answer, 14, is wrong. It doesn't work. You can't do it. So we need a different way to solve that. And so we need a new set of equations. So why can we not solve the problem above with the current equations? The reason why is because v equals d over t only works if a equals 0 and it isn't 0. We can only do that if a is 0. And if a isn't 0, we can't do it. We got to do something else. So we need to do something else. Okay, it's time for the kinematic equations. So there are 3 of them. And to help you remember them, now you don't have to memorize them. I'm going to give them to you all the time. Okay, you don't have to memorize them. But in order to help you remember them so you know which ones we're talking about, I gave them silly names. Okay, they all have silly names. This is not, I don't want you, like physicists didn't actually name them this. This is ridiculous me came up with silly names. Okay, first one is called Old Faithful. And the reason why it's called Old Faithful is because it's the easiest one to use, and it's the one you'll use most often. And that equation is VF equals VI plus AT. Now, I'm not going to explain the symbols. They're the same symbols we've been using. A is acceleration, T is time. VI is initial velocity, VF is final velocity. So we're not doing anything new there. Okay, so that's the first one. Second equation is called the Big Chalupa. Okay, the reason it's called the Big Chalupa is because it's the largest equation that we have, and it's the spiciest equation that we have. And that is D equals VIT plus 1/2 AT squared. This one can be kind of dicey to solve. So if you ever get into a part where you're like, oh my gosh, I'm not sure how to solve this equation, you can solve in 2 steps instead of 1 by using the other equations first. So that might be an option if you have trouble with this one. As I mentioned, this one is a little spicy on the algebra sometimes because of the t and the t squared. That sometimes throws people off. Okay. And the last one is called Ain't Got No Time. And the reason it's called Ain't Got No Time is because it ain't got no time in it. I started running out of creative ideas. VF squared equals VI squared plus 2AT. Bam! And those are the equations. There are 3 of them. They're all used for solving different things. Now, here's something that might be helpful to you as you try to figure out which equation, because this is kind of overwhelming for people sometimes to figure out what equation to use. Like, which one do I use? How do I know which one I need to use? We'll talk about how to figure it out, but here's something that might be helpful. Off to the side, I'm going to write what the equation doesn't have, because there's 5 variables, VF, VI, AT, and D, and each equation is missing one of them. So if you don't have D, you would use the equation without D in it. Now, that's not if you want to solve for D. If you want to solve for D, you need D in the equation. But this first equation has no displacement in it, so Old Faithful has no D. Big Chalupa has no V final. And Ain't Got No Time has no time. And that sometimes is helpful in figuring out which equation to use. Okay, so let's solve the example problem, but let's, try something new and do it correctly this time. So I'm not going to redraw the picture. It's the same picture as we had up here before. What I am going to do is write down the values again, just so I have them. So the values that we had for this problem are the initial velocity of 10, the final velocity of 0, the acceleration of -7, and the displacement of what we want to solve. Okay, so there are two ways to figure out what equation to use. Here's the way I figure it out. I look at these values here, and I say to myself, what equation has all four of those things? What equation has all four in it? Because there's only one. There's only one that has them all. Yep. Nope, not Big Chalupa. Ain't got no time. So I look and I say, okay, Old Faithful, does it have VI? Yes. Does it have VF? Yes. Does it have A? Yes. Does it have D? No. Okay, Old Faithful's out. Big Chalupa, does it have VI? Yes. Does it have VF? No. Big Chalupa's out. Ain't got no time. Does it have VI? Yes. Does it have VF? Yes. Does it have A? Yes. Does it have D? Yes. So I write down the equation. VF squared equals VI squared plus 2AD. And some of you used the other way, I could tell. You said, okay, which equation doesn't have time? Because there's no time here. Which one doesn't have time? Ain't got no time. That's the equation. Totally fine. Absolutely, that works. So let's plug the numbers in and solve and just make sure that we can get a different answer here. So VF squared is 0 squared. VI squared is 10 squared plus 2 times negative 7 times D. So we're going to square 0 to get 0. We're going to square 10 to get 100. We're going to multiply 2 and negative 7 to get negative 14. And D comes along for the ride. We're going to subtract 100 to both sides. And then we're going to divide negative 14 to both sides. And when we do that, we get 7.14, which is not even close to 14. That is the correct distance. That is the correct value. Okay? So you're solving problems very similarly to what you did before. The difference is now you're having to solve with different equations because the problems you're getting are a little bit more complicated. So go ahead and go to the back page. Okay? Here's your assignment for next time. This is all you need to do. This problem on the back. So a car is stopped at a stop sign when it accelerates to 35 meters per second over the course of 71 meters. Draw a diagram and list your knowns and unknowns. Find the acceleration of the car and figure out how long it took for the car to get up to speed. Okay? You'll use your equations from the front page. You use your Old Faithful, your Big Chalupa, your Ain't Got No Time. You're going to draw your diagram and do your unknowns and knowns first. Once you've done that, then figure out how to solve for A. Once you've done that, figure out how to solve for time. Okay? So go ahead and get started there. This is all you need to have finished for next time, and it's all you, and you have the rest of the period to work on it. So you got a lot of time here. If you need to borrow a calculator, come on up and borrow one. See if you can solve.